My name is Jerry Wu. I received my PhD from GWU at year 2008. Main focus are MEMS device specific for RF design. that was my PhD. So this is the course outline. And I briefly, again, today's lecture is going to go over the overview, okay? So these are the important components that we are going to discuss in this lecture, including what we're going to discuss today, cell balance, in other words, a little bit history. And then memory-based learning, behavior-based robotics, and reinforcement learning. These three lectures are very fundamental algorithm is actually for robotics control. Especially for reinforcement learning or behavior-based of the robotics, these are very useful for your final project. And reinforcement learning, for example, probably nothing new from you guys, right? But you learn reinforcement learning probably for some certain different application. But in this class, we specifically focus on robotics. And some other learning algorithms, like, for example, Q-learning, actor-critic, and robot shaping, close the reality gap, imitation. I'm going to show you, in this class, I'm going to show you some example of the video, and we are going to discuss the deep learning as well, and then followed by lifelong learning. This is the real robot. We have a lot of things right over here. Some interesting robot is like, for example, warehouse, right? In Amazon warehouse, you're going to see a lot of this. And then, again, this is not really look like a robot. It looks like a small car, right? We have a robot like this. This is very popular for what? Even for the military purpose now. They use motor, electronic. Because of motor, there are two major characters that the regular vehicle cannot accomplish. Number one, no infrared signature, or very low infrared signature compared with engine. Silent. With engine, you hear a lot of pum pum pum, that kind of noise, right? But with electronic motor, you only hear very, very small noise. So that's why it's very popular for the military purpose. You guys see this in regular Costco, so I'm going to repeat, but even though this does not look like, you and me, but we still call robot. This is a kind of interesting robot that help you to clean up some certain, this is turbine, right? But you can have some similar kind of thing for utility pole or even for building, okay? So that kind of robot. This is in the air. In the air can have, like, for example, for communication. You can use this for communication either for emergency or even for the military purpose. Somebody actually designed this kind of robot in military purpose, even though it looks like an airplane, right? And this is very popular. You guys know this, right? Mission to Mars, and we have a lot of projects like this, right? And this is like for toy, right? Toy. So I'm not going to repeat. So these are the some certain definition and example of the robot even on the market. This is the definition of the machine learning. We're talking about robot learning, right? So we discuss about what robot is or what are the robot structure. Now, what about machine learning? What does machine learning really means? So the first one is Tom Mitchell. So his definition is actually a computer program that improve the performance at some task through experience. So you have a program, you can do something better based on experience, which is history, time, t minus something. So look at the other one. Say that machine learning is the study of the data. You have the data now. Data-driven methods capable of mimic understanding and aiming human and biological information processing task. So now, not just data, not just processing. This person mentioned about human and biological. Now, the other one is machine learning algorithm can figure out how to perform the important tasks by generalizing from example. This is very similar to what we discussed previously, right? You have a database concept somewhere. At the basic level, machine learning is about predicting the future based on the past. So we have what? Time t minus I. So if you put together of all these very popular people or knowledge people's definition of the machine learning, we have the followings. Number one, some database or experience somewhere. Number two, some program that you can further improve, right? Further improve. Not getting worse, at least, right? Number three, we're talking about the database in the past timing. In other words, time t minus I. Eventually, we are going to introduce the Markov decision process, which is actually correlated to this.